to our mathematics class. This is a second video on coordinate geometry. We discuss certain problems and we further proceed to do different kinds of problems in coordinate geometry. Right? Here, one of the basic problem, find the value of x. If the distance between the points x comma minus 1 and 3 comma 2 is 5, they given, right? We need to find the x value such that they already given the distance between these 2 points as 5. You see, dear students, how we will do this particular problem? You know that the first point A is what? X comma minus 1. Let us equate with x1 comma y1, right? Fine. And B is what they given that 3 comma 2, and let us equate this with x2 comma y2, right? Like this. Now you know x1 y1, x1 is x and y1 is minus 1, x2 is 3, y2 is 2. You have got here. Now the distance between AB, the formula is given by x2 minus x1 whole square plus y2 minus y1 whole square. This is the formula you have like this. Now you just put it in the formula here, x2 minus x1, that is now 3 minus x whole square plus y2 minus y1, right? y2 is 2, 2 minus of minus 1, that is 2 plus 1 whole square, right? 2 minus of minus 1, that is fine. Okay. Now this problem, find the value of x if the distance between the points, right, x comma minus 1 and 3 comma 2 is 5, right? As we know that we have taken A, x comma minus 1, that as the first point x1 comma y1, B as 3 comma 2, x2 y2, and you apply the distance formula, x2 minus x1 whole square plus y2 minus y1 whole square, and that is now 3 minus x whole square plus 2 plus 1 whole square, that equal to 5. Now it's very simple. This is a minus b whole square formula. You expand that. A square plus b square minus 2ab plus 2 plus 1 whole square, that is 9 equal to 5. Here you do squaring on both sides. This is x square minus 6x, 9 plus 9 is 18 equal to 25. After doing squaring on both sides, this we got now x square minus 6x plus 18 minus 25 equal to 0. Now this is nothing but, my dear students, x square minus 6x minus 7 equal to 0. And by factorization, we will get that x minus 7 into x plus 1 equal to 0. This is now x is equal to 7 or minus 1. In this way, we have got nicely the values of x, 7 or minus 1, right? In this way, we will be getting this particular problem. Now the second problem, if the points A 4 comma 3 and B x comma 5 are on the circle with center O 2 comma 3, find the value of x. You see, dear students, we are having a circle here and the center O 2 comma 3. We have like this 2 comma 3. Now A 4 comma 3 like this. A 4 comma 3 is one point lying on the circle. And another point you have here like this, B x comma 5, that is also lying on the circle. Now you know that it is a circle means the radius is same, OA equal to OB. These both are nothing but the radius, right? That means you see OA is equal to OB, right? Now let us find the distance between these 2 points. Right? Now the distance between O and A, that is square root of, if you take this as x1 y1 and this as x2 y2, x2 minus x1, that is 4 minus 2 whole square plus 3 minus 3, y2 minus y1, 3 minus 3 whole square, that is equal to, here also here x2, okay, this is x1 y1 and this is x2 y2, that means x2 minus x1, x minus 2 whole square plus 5 minus 3 whole square, and this is here, let us simplify that, this is 0 and 4 minus 2 whole square is nothing but right, 4 minus 2 whole square. This is what we are having, square root of 4, right, and this is 0. We have like this. So now this is nothing but square root of x minus 2 whole square plus 5 minus 3 whole square, that is also 4. Now what we do is squaring on both sides, SOBS. that means squaring on both sides. If you do, what you will be getting, that is 4 is equal to x minus 2 whole square plus 4, you will get like that. And this 4 we can cancel, that means x minus 2 whole square is equal to 0 you have got. That means x minus 2 equal to 0, x equal to 2 comma 2. That means it is repeated root and x value is nothing but, finally we say that it is nothing but 2. X minus 2 equal to 0, 2 comma 2 means x value is finally 2, right? And it is a repeated root because it is a quadratic equation with degree 2, and it is a repeated root means x is equal to 2 is the value what we require to find here. Now we have one more interesting problem, the third one. Find a point on x-axis which is equidistant from a 2 comma minus 5 and b minus 2 comma 9. These 2 points. Okay. Now any point on x-axis is of the form, my dear students, x comma 0. We already mentioned that this is negative x-axis you are having here, and this is positive x-axis you are having. Any point on the x-axis whose y coordinate becomes 0. Therefore any point on x-axis will be x comma 0. They given, this is the rough diagram of this statement which indicates the given information. Like a is 2 comma minus 5, right? 2 comma minus 5 means just we have taken here, this is what, some point 2 comma minus 5 which lies in the 4th quadrant, and minus 2 comma 9 which lies in the 2nd quadrant. This is the point. Now we need a point which lies on x-axis somewhere else, we don't know that. We need to find that particular point which is equidistant to these 2 points. So let us take this as P, and if you take this as some A and B, that means for us it is given that PA is equal to now PB, right? Now using this information, PA is equal to PB, now we will get the equation and we solve it and we will get the x values here. You observe. Okay. Now we have got the condition PA equal to PB, right? And P is the point x comma 0, right? And A is 2 comma minus 5 and B is minus 2 comma 9. Now PA means the distance between P and A. Let us take this as x1 y1 and this as x2 y2. That is now square root of x2 minus x1 whole square plus y2 minus y1 whole square. And same way PB also, P and B. Okay, square root of x2 minus x1 whole square plus y2 minus y1 whole square. You apply this. Right, here x2 is 2 minus x whole square minus 5 minus 0 whole square, that is y2 minus y1 whole square. And PB also minus 2 minus x whole square plus 9 minus 0 whole square you are having. Now by doing squaring on both sides, the square root will be cancelled, and if you simplify this, x square plus 4 minus 4x plus 25 is equal to 4 plus x square plus 4x plus 81. This x square and x square will be cancelled. Now you have got minus 4x plus 29 is equal to 4x plus 85. And this minus 4x, this 4x let us transfer to this side. Then we will have minus 8x is equal to 29 minus 85, that is 56. Right? Sorry, this is what we have got, 29 we transfer to the right side. We will get that 85 minus 29, that is 56. X is equal to 56 by minus 8, that equal to minus 7. Therefore x value is equal to minus 7 is what the required x value. Like this you will be having some different kinds of problems. And one more problem, find a point on y-axis which is equidistant from these 2 points, also they may give the problem. When a point which lies on y-axis means you need to take the point on y-axis, x coordinate becomes 0. You know that on y-axis, suppose if you take like this, on y-axis the point x coordinate becomes 0. Now you take, this is something like 0 comma y, and 2 points A and B they given like this, right? This is P, PA and PB. Now you equate in the same way you do that, you will get, I am just telling you how differently they will ask the problems. Even for those type of problems also, you should know how to do these type of different problems. Now we have some important results or properties based on the distance formula. That's why we call them as distance properties. by just finding distance, we can decide some of the results, some of the facts. The first one, nature of a triangle. Next we move on to quadrilaterals also. First one, if you using only distance formula, how you can say, if you want to decide whether one triangle is an equilateral triangle, then it is enough that if you prove that AB equal to BC equal to CA, you know how to find it. They will give three vertices, right? They will give three vertices like this, A, B, C. They will give three vertices. This is something like x1, y1, x2, y2, x3, y3, like this. If they give three vertices, right? If they give three vertices, you need to find the distance between A and B, right? AB, and the distance between B and C, BC, distance between A and C, AC. Now, if you prove that AB equal to BC equal to CA, then it is enough that it is going to be an equilateral, it is going to be an equilateral triangle. Okay, therefore, using only distance formula, how you will prove a triangle as an equilateral triangle if they give the 3 points, three vertices means, if you prove that AB equal to BC equal to CA, you know how to find distance between AB, you know how to find distance between BC, you know how to find distance between CA. By that you can able to decide once all the lengths of the three sides are equal, then you can say that it is equilateral triangle. In the other one, if you have, suppose if you want to prove triangle ABC is an isosceles triangle, then also here it is enough that if you prove, you know how to find. First you just find the distances AB, BC and CA from the triangle, which okay, the lengths you prove that, of course. Suppose if you have that here AB equal to BC, then also it is equilateral, this is isosceles triangle like that. And another case, suppose if you have that, okay, ABC like this, AB equal to AC, this is also an isosceles triangle in this case also. Next, suppose if you have a triangle ABC like this, BC equal to AC, in this case also it is an isosceles triangle, right? Any two pair of sides, one pair of sides are equal, that means AB equal to BC or AC equal to AB or BC equal to AC, then we can say that it is an isosceles triangle, right? Now we have how to prove given triangle is a right angle triangle. Whenever they given three vertices A, B, C, they give, right? If BC is the largest side, of course, then you know that you know how to find BC, you know how to find AB, you know how to find AC using distance formula. Once they give the three vertices to you, then if that triangle satisfies BC square is equal to AB square plus AC square, then we can say that triangle ABC is a right triangle. This is a right triangle. We can say that this is a right triangle. Right angle that, okay, right angle here, angle A is equal to 90 degrees we are going to have, right? That means if you want to prove, if they give that three vertices A, B, C, if you want to prove it is a right angle triangle, the only thing you require to prove is square of one side. Square of one side is equal to sum of the squares of the other two sides, right? Suppose if you have that like this, suppose if you have that ABC, okay, in this case, suppose if it satisfies this property means AC square equal to, we will have AB square plus BC square. In this case, we say that angle B is 90 degrees, we will say that. Or the other case you may have even, suppose like this, right? You may have here A, here C and B here like this. In this case, if it is 90 degrees, then you are going to get that AB square is equal to AC square plus BC square like this. AC square plus BC square. These are the things that you are going to get to prove it is a right angled triangle, right? That means square of one side, if you are able to prove sum of the squares of the other two sides, then it is nothing but a right angled triangle. Now the fourth one, suppose for any triangle if you get AB square plus BC square is less than AC square, something like this, right? You have got A, C like this, here B like this, right? AB square plus BC square is less than AC square, then we can say that triangle ABC is an acute triangle, like acute triangle. This here angle B is an acute angle triangle. That means sum of the squares of any two sides is less than square of the third side. Okay, then you can say that it is an acute triangle, acute angle triangle. Sum of the squares of two sides is less than square of the third side, then you can say that triangle ABC is an acute angle triangle. Now you see another one we can have AB square, suppose plus BC square, right, is greater than here, is greater than now AC square, like this. If it is greater than AC square, then we can say that triangle ABC, this triangle ABC is an obtuse triangle, like this, is an obtuse triangle, like this. Fine? Fine. Triangle ABC is an obtuse triangle. That means, you see, my dear student, suppose you are having like this, right? Like this. Here A, B, C. Here. This is an obtuse triangle such that you have got here that AB square plus BC square is greater than AC square, like this. AB square plus BC square is greater than AC square. Then you can say that right here. Now the fourth one, AB square plus BC square is less than AC square. Then triangle ABC is an obtuse angle to triangle, like that. You see here AC square BC. Suppose anywhere if you get that sum of the squares of two sides is less than the square of the third side, then it is obviously an obtuse angle triangle. And the other, the fifth one you are having here, sum of the squares of two sides is greater than the square of the third side, then triangle ABC, that becomes an acute triangle. Okay, acute triangle. And this is what the diagram for that, what you are going to have, like this. Suppose you have like this, it is right A, C and B, like this. Here you have got AB square plus BC square is greater than AC square, then triangle ABC is an acute angle triangle, right? That way you can decide which triangle it belongs to. Now we have nature of a quadrilateral using only the distance properties. If you want to use distance properties here, suppose if you want to prove a parallelogram, they will give 4 vertices. Okay, if you want to prove it is a parallelogram, like this, suppose you know that you just prove that opposite sides are equal. Okay, you know that ABCD is a parallelogram. If it is a parallelogram, opposite sides are equal. If you just prove that AB equal to CD, right, and AD equal to BC, then it is enough that it is nothing but a parallelogram. Only using distance formula. There are many other properties to prove parallelogram, but only using distance property we can say that if opposite sides are equal, then we can say that it is a parallelogram. That means here you require to prove AB equal to CD and AD equal to BC. In this way you will be proving this as a parallelogram. Now the second one, if you want to prove a quadrilateral, given quadrilateral as a rhombus, using distance formula, distance properties, only that if all 4 sides are equal, like this, if all 4 sides are equal, then it is a rhombus. Basically it is a rhombus, right? If all 4 sides are equal, if you prove that, then okay, only using distance formula, you know that how to find distance between the vertices AB equal to BC equal to CD equal to DA, then you can say that it is nothing but a rhombus, right? You have here now AB equal to BC equal to CD equal to DA. If you prove all these sides are equal, then it is enough that it is nothing but a rhombus, right? Now the third one, if you want to prove any quadrilateral as a rectangle, right? If any quadrilateral as a rectangle using only the distance properties, distance formula, you know that what you require to prove is if ABCD is a rectangle, you know that opposite sides are equal and diagonal lengths are also equal. Diagonal lengths are also equal. That means AB equal to CD is one thing, and AD equal to BC is opposite sides are equal, and you have to prove the diagonal lengths are equal. AC is equal to BD, like this. AC is equal to BD. This is what you require to prove, right? If you want to prove a rectangle, you prove opposite sides are equal and the lengths of the diagonals are equal, then it becomes a rectangle, right? Now the fourth one, if you want to prove any quadrilateral as a square, you know very well that all four sides are equal, right? All the four sides, A, B, C, D, all the four sides are equal and the length of the diagonals are also equal like this. That means, you see, my dear students, this is equal to this. You have to prove that AB equal to BC equal to CD equal to DA and AC is equal to BD like this. Right? You need to prove all four sides are equal and the lengths of the diagonals are also supposed to be equal. That is what the way how we will prove any quadrilateral given. Any quadrilateral you want to prove it is as a square. Like that we have some basic problems on proving these things. Now the fifth one, you want to prove if they give 3 points, if they give 3 points as collinear points. Collinear points means they have to lie on the same straight line like that. They have to lie on the same straight line, right? Okay, they have to lie on the same straight line like this. You have A, B, C, they given 3 points like this. You need to prove them as collinear points only using distance formula, using distance property. How you will be proving is in one way. Here see the distance between AB, this plus BC, okay, AB plus BC, this is equal to, you have to prove it as AC. If the 3 points are like this, if you prove that right, AB plus BC equal to AC. Suppose you have some situation like that, B is here, C is here, A. Then if you want to prove that these 3 points are collinear, means in this case you have to get BC plus CA is equal to, you need to prove it as BA like this, right? This is another way of proving. Suppose the other possibility also you are having here, okay, you have here C and you have here A and you have here B like this. Suppose you want to prove these 3 points are collinear, okay. Collinear means they have to lie on a same straight line. Then in this case what you will be doing is CA plus AB, right, is equal to, you have to prove it as CB. Once they satisfy this type of property, then you can say that those given points are collinear. Okay, this is, we are proving they are collinear by only using distance formula. You know how to find distance between 2 points. Now based on that we have a wonderful problem. Do the points A, B, C they given form a triangle? If so, means name the type of the triangle, right? And you see this particular problem, let us take A, B, C. A is this 3, 2, B is -2, -3, C 2, 3. Let us find the distance between AB. AB using, see here, A you take it as x1, y1, B you take it as x2, y2. Now square root of x2 minus x1 whole square plus y2 minus y1 whole square. If you do that, this is now square root of 25 plus 25, that equal to square root of 50. You are going to get that as square root of 50. Now BC equal to, this is now, right, BC, this you take it as x1, y1 and C you take it as x2, y2. Then this is now x2 minus x1 whole square plus y2 minus y1 whole square. That if you do, you will get 16 plus 36 root 52. You are getting that. And CA, in CA also while you are doing this, you take one of them x1, y1 and another one x2, y2. No problem. Anything you can take as x1, y1 and anything you can take it as x2, y2. Then if you find distance between C and A, you are going to get the square root of, this is now 2 minus 3 whole square plus 3 minus 2 whole square, that is square root of 1 square minus 1 square plus 1 square, that is square root of 1 plus 1, that is square root of 2. And we can easily observe that here BC square is equal to AB square plus CA square. BC square is root 52 whole square is equal to root 50 whole square plus root 2 whole square. That means 52 equal to 50 plus 2, that is 52. That means we have got here this property is satisfying. BC square is equal to AB square plus CA square. That's why this BC is acting as a hypotenuse and these two other sides are acting as legs further. Therefore, it is a right angle triangle, right angled at A, right? In this way, you can do this particular problem. Now we have one more point to show that the points fifth one, A 1 comma minus 1, B 5 comma 2 and C 9 comma 5 are collinear. You need to prove that they are collinear, right? For that what we do is, as I told you, that let us find AB, BC, CA. Let us find now AB. AB is nothing but now square root of, let us take this point A as x1, y1, B as x2, y2. Now x2 minus x1 whole square, that is 5 minus 1 whole square plus 2 minus of minus 1 whole square, that equal to now square root of 4 square plus 3 square, that is root over 25, that equal to 5. In the same way now BC. Now BC is equal to, let us find using the distance formula, that is 9 minus 5 whole square plus 5 minus 2 whole square, like this. This is nothing but 9 minus 5 is 16, 5 minus 2 is 3, this is 9 square root of 16 plus 9, that is root 25, that equal to 5, like this. And in the same way you are going to find CA, right, AB, BC and AC. Let us find the distance between A and C. That is nothing but if you take A as x, now the distance between A and C, you are going to get that as 9 minus 1 whole square plus 5 plus minus of minus 1 whole square, like this. This is nothing but 8 square plus 6 square, that is now 4 plus 36, that is root 100, that equal to 10. You have got it as 10. Therefore, my dear students, you observe that here, okay, AB, you are having AB here and BC is here, like this, right? AB, BC, and if you add AB and BC, this is AB is 5 units, BC is 5 units, and AC you have got it as 10 units. That means 5 plus 5 is equal to 10. That means they are all, it is satisfying the property what AB plus BC is equal to AC. If they are on the straight line, then only this property will be satisfied, right? If they are on the straight line, then only this property will be satisfied. If they are not on the straight line, then they will form a triangle. We can say that they are not collinear. But we have got that AB plus BC equal to AC. That means that these 3 points are collinear, right? In this way we can prove this problem. Now we have one more problem on quadrilaterals. They given sixth one, if P 2 comma minus 1, Q 3 comma 4, R minus 2 comma 3 and S is minus 3 comma minus 2, then prove that PQRS is a rhombus but not a square. How we will be doing this is the solution part, my dear students. We want to prove this is a rhombus but not a square, means we need to prove that rhombus means all 4 sides are equal. PQ equal to QR equal to RS equal to SP we need to prove, and we should prove that their diagonals are not equal. Let us see that we have found now PQ. P and Q is given x1 y1 x2 y2 square root of x2 minus x1 whole square plus y2 minus y1 whole square, and that equal to, okay, 3 minus 2 whole square 1 square plus 5 square root 26 we have got now. Now next in the same way let us find QR, like QR also you take this as x1 y1, now this is x2 y2. That means you are going to get minus 2 minus 3 whole square plus 3 minus 4 whole square, like this, right? Once you get that, this is nothing but however 25 plus 1 root 26 you have got, like this. Okay, minus 5 whole square, that is 25, right? QR. Next you have here RS. Let us find RS. RS. How we will, this also you take as x1 y1 and this as x2 y2. Then you have minus 3 minus of minus 2 whole square plus minus 2 minus 3 whole square, like this. This is now this equal to minus 3 plus 2, that is 1 square, that is 1, and a minus 5 whole square 25, that equal to root 26. You got this way. Now PQ, QR, RS and SP, like this. SP or PS, like this. Now this is SP means you take S as x1 y1 and this as x2 y2. Now this is minus 3 minus 2 whole square plus minus 2, okay, plus 1 whole square, minus of minus 1, that is plus 1 whole square, that you are going to get. This is also 25 plus 1, that is root 26 you have got, like this. And one more thing here, you got now all 4 sides are equal, therefore it is a rhombus, no doubt in it. But we should prove that it is not a square, right? To prove that it is not a square. In a square, all diagonals are equal. Now let us find the diagonal here. The diagonal, suppose you have a rhombus, this is the shape. If you have for a rhombus like this, okay, P, Q, R, S, like this, they given those. Now we need to find PR and the QS. Let us find now PR here like this. Okay, if you find PR here, P and R, x1, y1 you take this and R you take it as x2, y2, then minus 2 whole square like this, plus 3 minus of minus 1, 3 plus 1 whole square, you have like this. That is nothing but square root of 16 plus and this is also 3 plus 1 whole square, 16. That is root 32 you have got here. Okay, one of the diagonal length you got it as root 32 like this, right? Fine. Let us find another diagonal. Now we have found PR and now let us find QS like this. Okay, if you find QS here also, like QS, if you find, okay, Q is this and S is this. You take this as x1, y1 and this as x2, y2. Now minus 3 whole square plus minus 2 minus 4 whole square like this. This is nothing but square root of, this is 6 square, 36 plus 36 and root 72. And we have got wonderfully in this problem, my dear students, you got that PQ is equal to QR is equal to, right, RS, and that is equal to SP. That means all four sides are equal, and also the diagonals here, PR is not equal to QS. PR is not equal to QS, right? Therefore, it is a rhombus and it is not a square, because in a square diagonals are equal. Here the diagonals are not equal. That's why, therefore, PQRS is a rhombus. You have got like this. Fine. Therefore, it is a rhombus.